We are going to see 4 to 5 examples again on the gradient on the same topic here. In last session, we seen the theory about a gradient. Already we know there are 3 parallel words for these questions. Whenever the question comes, find the gradient of the given scalar function, find the directional derivative of the function phi, or the third, find a normal vector to the surface, then we have to do the same calculation. Can you tell me the step number 1 here? What we should start here? Yes.
Let phi equals to xy cube z square equals to 4.
Okay, so first of all, we should write let phi be the given function. So just we give a notation, so which is x y cube z square is equal to 4. Then
We'll apply the formula.
therefore we should calculate del phi. Okay,
Yes,
so del phi is actually the normal vector to the surface. So del phi is a dou phi by dou x. Yes, generally keep a habit of writing the formulas. Uh, in the exam, many times you are not writing this formula, you write directly the calculation. It's better you always start with the formula. So that about the formula. Yes, tell me what is the dou phi by dou x?
Y cube Z square.
Yes, y cube z square. Dou phi by dou y.
X 3y square Z square.
Yes, correct. And dou phi by dou z.
XY cube 2Z.
X y cube z k cap. So this is a general normal vector. This is normal vector at any point x y z. We want that normal vector at this point. So let me say at 1 minus 1 2 at this point. Yes, anyone?
So we'll substitute that value in that
Yes,
equation.
what will be this then value? Is it minus 2 I
Oh,
cap?
yes, sir.
Then
Sir, it will be minus 4, I think so.
pardon?
Minus 4. Like minus 1 cube and 2
Yes,
square.
correct. Minus 4, correct. My mistake. Minus 4 I cap, then
12J cap.
12 J cap, correct. And lastly,
My, minus 2K cap. Minus 4K cap, yeah.
4 K cap. So step number 1, general normal vector. Step 2, we get a particular normal vector at a particular point, but the question is about unit normal vector. Okay, so I can write this vector like this. I will take 4 as a common, and we can write it like minus I cap plus 3j cap. Okay, plus 3j cap minus k cap.
Yes, sir.
This is a 4 is just a common multiple of the components. Therefore, unit normal vector, the last step. Therefore, unit normal vector, the formula says it is a del phi divided by mod of del phi, its
Model.
magnitude. Correct. Now, yes, this 4 automatically gets cancelled, because if you take only you have to just divide by magnitude of this. This 4 will get cancelled with its magnitude only. So I can write minus I cap plus 3j cap minus k cap divided by square root of 1 plus 9 plus 1. Okay. If you keep 4 inside and do that, you will get the same answer. And last step, you will have this as answer. If anyone have a doubt, you can ask. So once you finish, tell me. We'll move to the next question then.
Yes, sir, done.
Done. Okay, good. So the second question. So example 2 is on the screen now. Find the directional derivative of the function f along PQ. So we already completed this type of the example, but it is a repetition. So we want the directional derivative of the function f along PQ. So the step number 1, Yes, step number one will be the del f vector. Is that del f is
So
equal to? So write a formula first, like dou f by dou xi plus dou f by dou yj plus dou f by dou zk. Yes, tell me now dou f by dou x,
2x
dou f by dou I,
minus 2y
and dou f by dou z.
minus 4z.
So this vector is known as a directional derivative. This is actually the directional derivative at any point xyz. This is general directional derivative. But we want the directional derivative at a point P. So we'll say at point P, which is a 2 minus 1, 3, directional derivative del f is equal to,
4i cap
correct?
4
Okay.
I cap
plus 2k j cap
Okay.
minus 12
minus 12k cap.
12 k cap.
12k. So this one gives us a directional derivative at a particular point. But we want the directional derivative along PQ. So PQ bar is equal to, yes, by it is a q bar minus p bar by the definition of position vectors there.
3i cap
Yes,
plus 7j
iu
cap
minus 2 I cap, that is a 3 I cap, correct.
7j cap plus 7j cap
7 j cap
plus k cap.
plus k cap, good. So we got pq bar vector, and now last step is left. We want the directional derivative del f along pq. So what should be done?
F dot pq by uh,
Upon mod of
Magnitude pq.
mod of
PQ.
pq.
So it is just like a projection. Okay, so we say directional derivative of f along pq bar is del f dot pq bar divided by magnitude of a pq bar. That about last step. So we should take a dot product now. So to take a dot product, yes, we take like a1 b1. So 4 into 3, that's 12,
12 plus 14 minus 12.
plus 14, good, and minus 12. So this is just like a1 b1 plus a2 b2 plus a3 b3 divided by magnitude of a pq bar. So it's a 9 plus 14
49
plus
Root
1.
plus
49. Root 59.
It's
14 by root 59.
yes, 14 by root 59, and that's the required answer. Okay, so questions are really simple. They are really simple. Only you should know how you should proceed step by step. That first we should calculate a general directional derivative, then particular, then the component. Okay, like that. So complete it. Once you complete, tell me. We'll move to the next question then.
Done, sir.
Done. Good. So here is a third question. It is straightforward, one of the simplest question. Step 1. We should calculate a del phi. That is a
2xi cap 2yj cap 2zk cap.
very good. It's one of the simple question, correct? And very simple derivatives are coming here. In actually vector calculus, we require hardly derivative of three functions: algebraic function, exponential function. Okay, uh, algebraic, exponential, and by chance sometimes we require product rule of differentiation. So that about yes. Next step we want at a particular. So
10, 2, 2, 1.
Root of
4 I
5
cap.
cap plus 4 j cap plus 2 k cap.
4 I cap plus 4 j cap plus
Yes,
k cap. Good.
yes, sir.
Lastly, we want
That will be
that.
plus 2 k cap, sir.
So let I say a bar is that direction. You can
Sir,
give
that
any
will be
direction.
2 k cap, sir.
Plus 2z. Therefore,
Excuse me,
directional.
sir.
Yes,
But that will be 2k cap, sir. Plus
Yes,
2k.
sir. 2
last
cap.
one. Yes, correct. Very good. So therefore, directional derivative of phi along a bar is equal to del phi dot a bar upon magnitude of a bar. And this way we get answer. So a1 b1 4 into 2 is a 8, a2 b2 again 8, a3 b3 is a 2 divided by magnitude of a 4 plus 4 plus 1, and check whether the answer it is a 16 plus
18 by 3, sir.
18 by 3, and the answer is a 6 then. Okay, so 6 unit. 6 unit is a component of a directional derivative along that vector a bar. So once you finish, tell me. Can we move to the next question?
Yes, sir.
Okay.
Yes, sir.
So here is a fourth example. Find the directional derivative of this function phi at 0, 0, 0 along a tangent to the curve. So it is a little different question, but one similar question we already finished. And the derivatives now you require like exponential into trigonometry. You require product rule. Okay. Uh, Actually, product rule is also not required. You will start it, you will come to know. So the question is find the directional derivative of a function phi. So we'll start del phi equal to the formula says yes dou phi by dou x I cap. So dou phi by dou x is like
2
yes,
e to the power 2x cos y z I cap
correct.
minus
Minus
cos
sign to the power
a
2x.
sine.
E raised to 2x will be as it is.
Yeah, z
Uh,
sine
Sin
yz
y.
Yes, correct. Simple.
minus e to the power 2x y sine yz. Okay, cap.
So that about general directional sorry, yes, general directional derivative. We want this at a point 0, 0, 0. Yes, anyone? What will left?
2 I cap.
Only 2 I cap. Good. Okay, because cos 0 is 1, sin zeros are zeros. So straightforward, del phi left only 2 I cap. Nothing there. Okay, like 2 I cap only. So that about first step is that this is general directional derivative at any point x, y, z. This is the directional derivative at a origin 0, 0, 0. So we say the directional derivative is along x-axis only. Okay, so it's actually derivative along x-axis. We got it here. But can anyone tell me how to get the tangent to the curve now? How to get tangent to the curve? Yes. How to find tangent to the curve? So you forgot it then. Hmm? The method of getting tangent. Yeah. 2 and 2, Madhav. Yeah.
By asymptote.
Pardon?
By asymptote, sir.
Asymptote. I'm not asking about asymptote. I'm asking a tangent to the curve we want here. So first we should write the equation of curve. Let
Yes, sir.
r bar is xi plus yj plus zk is the equation of the curve. and here x is a sin t, a sin t I cap plus a cos t j cap plus a t k cap.
Yes, sir.
So this is the position vector of the moving particle. And how to get a tangent now?
So we will
So this
differentiate with
derivative
dr by
respect
dt.
to t and then put the value of
dr
t.
by dt.
Correct. Therefore, tangent t bar is a dr bar by dt. Tangent t bar is a dr bar by dt. And let me differentiate it to become a cos t
A cos t minus a sin t
minus a sin t, correct,
plus a.
plus a k cap. So that about a tangent vector t bar. And lastly, we want this tangent, actually we want a tangent at t equal to pi by 4. So at t equal to pi by 4, t bar tangent vector is, what is cos pi by 4?
By root 2.
1 by root 2.
Yes, 1 by root 2 I cap minus a by root 2 j cap plus a k cap. And what about the last step now? The last step we left is a component. Therefore, directional derivative of phi
Phi dot unit vector
along
of
t bar is del phi dot t bar divided by magnitude of a t bar. But here, when you take del phi dot t bar, actually a1 b1 only left. So it will left 2 into a by root 2. 2 into a by root 2 divided by, yes, anyone, what is the magnitude now? Magnitude goes as a square root of,
it is root 2.
yes, it is a just first we'll write it a square by 2,
1 by 2. A by 2
a
means a
square
square by
by
2.
2 plus a
Yes.
square by
What?
2 plus a square.
A square. Yeah.
Okay, so what happens, the numerator, I will write it here, the numerator will become this, one of the root 2 gets cancelled, numerator will left root 2a. And let me see the denominator, a square by 2 plus a square by 2 is a square plus a square is a 2a square, so that also goes root 2a, and we'll get the answer as 1. So final answer is just number 1, that about the directional derivative of phi along the vector t bar there. If any doubt is there, yes, you can ask, because it is a little different question. So are you completed all these examples? Any doubt there?
No, sir.
No. So I'll move to the next question then. Hope all of you written it. So it is again repeated question. Find a unit vector normal to this surface at this point. Okay. Answer is not there. So complete it and tell me the answer. Complete this question and you should tell me the answer. Anyone completed? No one. No one got the answer.
Minus I cap plus j cap by
Just,
root 2.
just, just a minute. I think who is talking? Uh, yes,
One.
right answer. Tell me.
Minus I cap plus j cap by root 2
Minus I cap plus j cap
by root 2.
to completely divided by root 2. All of you got the same answer? Okay. Let me see here. So for solution, first of all, let me start with a phi. Let phi is the function which is x y square z. Remember, each and every term we should say on the left hand side only. So minus 3x minus z square is equal to 0. So function of x y z equal to constant. That is a form of the scalar function. So you can take either these three terms, this single term on that side or these two terms on left side, both are the same. Therefore, the first thing we require a general normal vector del phi, which is a dou phi by dou x, which is a y square z.
Minus 3.
Yes, minus 3 I cap
Okay.
plus dou phi by dou y
2xyz j cap.
2xyz j cap, and lastly dou phi by dou z.
X square yz
No,
minus
xy
2.
square minus 2z
Minus 2z, yeah.
k cap. So that's about a general direction, general normal vector. We want that vector at minus 1, minus 1, 2. So at this point, now del phi will become, just to replace y by minus 1, z by 2. So 2 minus 1, so there's minus I cap, is it? Then here, this is a x, y, z. So it is a plus 4 j cap. And lastly, xy square. So it is 1, sorry, minus 1, and minus 1, minus 4, minus 5. Is that correct?
Yes, sir.
Yes, yes, sir.
So we got here this normal vector at a particular point, but the question is not that. Question is find unit normal vector. Therefore, unit normal vector is equal to del phi divided by its own magnitude.
Root 42, sir.
Yes, the answer will come, which is a minus I plus 4z
Plus 4 j cap minus 5
Minus
j
5
cap
j cap upon
upon root 42.
divided by, okay, first I'll write in a square root, 1 plus 16 plus 25, and that is 42. Is that
Yes,
Sir.
sir. Yes, sir.
minus I plus 4j minus 5k upon root 42 is the correct answer. So whatever the answer already given, that's not correct. So this is the wrong answer that we have. I think the mistake probably hidden, not
So 1 comma minus 1 to I2. By
okay,
mistake.
1 comma. So this silly mistake you should not do in the exam. Okay, you should see whatever the given. Okay, yes, there is a little difference in minus sign there, so that may you confused, but it is minus 1, minus 1.
Yes, sir.
Okay, okay. Any doubt, anyone here?
No, sir.
No, sir.